This is Quick Clip 1.02, work and power equations. And the first thing we should cover is the first requirement for work to occur is that there is movement. And we can prove that by looking at the formula for work, which is work equals force times distance. So the man here is holding a box, but he's not moving anywhere. And although he is using a force to hold up that box, because he's not traveling anywhere, there is no work. So if we plug in that information into the formula, work is going to equal the 10 newtons it takes to hold the box, but it's going to be multiplied by a distance of 0 meters. And so when we multiply that out, of course, then work equals 0. So one of the first things that they talk about in this lesson is that work requires movement. Objects need to move. So when we do have movement, for instance, the man is going to be walking with that box across the screen here. Again, his force is 10 newtons to hold the box, and then he's going to walk a distance of 50 meters across from the left to the right. And so now we have work equals the 10 newtons of force times the 50 meters of distance. And so work equals 500 Newton meters. And a Newton meter is another way of saying the unit for work, which is joules. So work equals force times distance. 10 newtons times 50 meters is going to equal 500 joules. Now the next thing the lesson talks about is power, and power is the rate that work is done. So in other words, how fast work is accomplished. And it's noted by the formula power equals work divided by time. So you can think of it as how much work is done every second. And in this example, we'll use the same amount of work that the man did in the previous slide, carrying the 10 Newton box and walking 50 meters to make 500 joules of work. But when they walk across, they're both going to walk across at a different rate. So you can see the man at top is going to be walking much faster than the man at the bottom. So they did the same amount of work. They carried the same box, the same distance, but one just did it faster. All right, the man at the top did it in 5 seconds. So his power is equal to the amount of work, which was 500 joules, and the 5 seconds it took for him to walk from the right to the left. So 500 joules divided by 5 seconds gives us 100 watts, and the watt is the unit of for power. The man at the bottom did, again, the same amount of work, 500 joules, but did it in 10 seconds. So in the formula, it would be 500 joules divided by 10 seconds, and we end up with a value of 50 watts for the amount of power. So to review, the formula for work is work equals force times distance. We have the example of 10 newtons times 50 meters, and work equals 500 Newton meters, or work equals 500 joules. Power, on the other hand, is the rate of which work is done, and our example was power would equal 500 joules divided by 5 seconds, or power would then equal 100 joules per second, and that would be equivalent to power equal 100 watts.